Alright guys, we are now looking at probability. So our first target is just our intro to probability. So our first master learning objective is I can calculate simple probability by identifying the favorable outcomes. So the first thing we're going to look at is vocabulary. Again, we go over this vocabulary, I tell you what it is. If you have questions still, what that means, you should ask. Don't know how we're using it, then we need to make sure we understand. Okay? So our first word here is experiment. An experiment is an act. Give me a second. An action so an experiment is an action that creates outcomes. So an experiment is something that you're actually doing. So for example, and my experiment could be rolling a die. Alright, just like we did in class. Alright, your experiment is rolling a die. Okay, so the outcome is like possibilities of an experiment. For example, in this rolling a die, my outcomes are 1, 2, 3, 4, 5, 6. Each of those are my individual outcomes. Outcomes, an event, an experiment are very different things. Now, our event is one or more outcomes that we really one or more outcomes that we find the probability of. If I can spell probability. So for example, event A, I'm going to say roll a 1. That is one outcome. The outcome is 1. Another event could be roll an even number. 2, 4, or 6. So it has 3 outcomes. So an outcome is just, we also can call it like our sample. A list of outcomes is also like our sample space. So we can list every single thing that could happen. And an event, I can choose one or more things to happen, and that's what I'm going to find the probability of. Okay, then what is actually probability? Probability is the likelihood of an event occurring. So how likely is it that that's going to happen? How likely is it that you're going to roll a 1? How likely is it that you're going to roll an even? Okay? And probability equals the number of the event or favorable outcomes over the number of total outcomes. example, for this one, 1 out of our 6 outcomes. For this one, I have 3 numbers in the event out of our 6 outcomes. Okay? So the number in the event versus the number of favorable outcomes. Or total outcomes. Alright, so for example, flipping a coin is an experiment. The action of flipping the coin is the experiment. And it has 2 possible outcomes. Your 2 possible outcomes are heads or tails. What is the probability of heads? Well, I have 1 head out of my 2 possible outcomes. Same thing for tails. 1 out of 2 possible outcomes. All right, looking at example 1 here. Jill and Henry are playing a game that involves this spinner. Right? Jill wins the game if the spinner lands on an even number. Henry will win if the spinner lands on 4 or higher. Using the spinner to the right, answer the following questions. What is the sample space? What can my spinner land on? My sample space, we usually put it in braces, which is what this symbol is called. It's kind of like a parentheses, right? I can land on a 1, a 2, a 3, a 4, or a 5. For listing my sample space, I don't care right now if they repeat. Okay? We're just listing my sample space. What is the probability that Jill wins? So Jill wins on an even number. We're doing probability of even. This is another notation. It's probability of whatever's in your parentheses. So I'm going to go through and I'm going to underline all my even numbers. 1, 2, 3, 4. Out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 possible options on my spinner. So 4 out of 12 equals 1/3. Again, we always reduce our fractions. Okay. What is the probability that Henry wins? And I like to use some shorthand. So Henry wins if it's 4 or higher. So if it's greater than or equal to 4. You could write 4 or higher. I prefer shorthand. So I'm going to count all the ones that are 4 or higher. 1, 2, 3, 4, 5, 6. And reduce. So now the question they're asking is this game fair? You should be able to look and see that no. Henry's probability of winning is greater than Jill's probability of winning. Okay. Games are fair when the probabilities are equal. All right, let's look at our next page. The next thing we have is the complement. So the complement of an event is the event, all outcomes except a given event. Another way we say it is like the complement is not the event happening. I want not tails. I want not a 2. I could get anything but a 2. Okay? Like when you roll a die. Anything. Okay? So the probability of what we call the complement of A equals 1, because that's everything minus the probability of A. Okay, so it's everything except A. Take out the probability of A. We're going to actually look at two different things here. So looking at number 1, what are the possible outcomes? Well, I have white, striped, and black. What is the probability of pulling a striped marble? Well, let's first say 1, 2, 3, 4, 5, 6, 10. I have 10 marbles in my bag. I have 1, 2, 3 striped marbles. Done. Probability of striped. What is the probability of a white marble? 1, 2, 3, 6 out of 10. Equals 3/5. Probability of a black marble. 1 black marble. That's it. That's me. Okay. Number 5. What is the probability of not pulling a white marble? So this is the same thing as saying the probability of the complement of white. Okay. Well, the probability of pulling a white marble was 3/5. So I could do 1 minus. Sorry, I don't know that right. Which equals 2/5. Okay. So that's one method of solving for your complement, just remembering that 1 minus 3/5. However, if there's a question, like if this is just a random question in a test, you might not already know that that's 3/5, so that actually might be more work. If we look at our 6, the probability of the complement of stripes. Well, what does the complement mean? Again, it's not pulling a striped marble. Well, that means I can pull a white marble. That's 6 choices. Or I could pull a black marble. So in total, I have 7 marbles that aren't striped. 7 out of 10. And you can just do that as well. Sometimes if you have all those options available, that is sometimes easier. Looking at number 7, what's the probability of not pulling a black marble? Again, 1, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 marbles that aren't black. Last one, what is the probability of pulling a polka dot marble? Well, if I look here, I have 0 polka dot marbles. Okay, so a probability of 0 means it's definitely not going to happen. I cannot pull out a polka dot marble. All right, that is it. I will see you guys tomorrow.